Welcome to Grade A with Caleb once again. My name is Caleb, and today on business statistics, we are going to look at measures of central tendency. Okay, so here we are going to look at what entails when we see measures of what central tendency. We say measures of central tendency is defined as what a single value that summarizes a set of data, right? It's it locates the center of what the values. Let's say we have a certain values, right? We have a certain data. So what we do is that after collecting the data or analyzing the data, we are going to use one particular number or one particular value that is going to represent the entire what values, right? In a way. So in doing this, we are going to focus on these the arithmetic mean, the weighted mean, the mode, the median, and geometric mean. Right. First off, let's start with arithmetic mean. When we say arithmetic mean, what is arithmetic mean? Arithmetic mean can also be called um, an average. Okay. So when we say arithmetic mean, what we are trying to say is that we are looking for a number, okay, a particular number that is going to represent the entire set of data, right? So let's say if I enter a class of 20 people and then they have their ages, right? If I want to find the average age of the class, what I have to do is that I have to add all their names, all their ages, and then divide by the total number, right? So arithmetic mean here is just um, the um, the average of what a certain values in question. Okay, so with this, we have two types of arithmetic mean. We have the population and the sample mean, right? We have the population mean and the sample mean. Now, with population mean, if you want to find population mean of any given values, what you need to do is that you say that population mean is equal to the sum of x divided by n. Now, this x you see here represents the individual values in the data that's given, right? The individual values that is given in the data. So you need to sum all the x values and then you divide by the total number. N means the total number of observations, like we learned there in the previous video. N is what? The total number of what? Observation. So if you have 10 people having different ages, we are going to say that their ages together divided by 10 is going to give us what? The population what? Mean. Let's take this example. We have this data here. We have 46, 52, 75, 40, 70, 43, 65, 35, and then 48. And we say that these are the marks obtained by 10 students. So these are what? Marks. These are the marks obtained by 10 students after they sat for an exam. And then we are asked to what? Find the mean what, or the arithmetic mean of their marks. That means on average, what is the average mark of the class? Right? That is what we are asked to do here. Okay? So all you need to do is to sum all of this and then divide by the total number. So we say that sum of x, the population mean, sum of x is equal to sum of x, that is 46 plus 52 plus 75 plus 40 plus 70 plus 43 plus 65 plus 35 plus 48, all divided by 10. Are we together? All divided by 10. This is going to give us 514 divided by what? 10. That is what? 51.4. So that means that the average, right? The average mark of the student is what? 51.4 marks. Are we together? Now, let's go to sample mean. X bar. Now, if you want to find the sample mean, let's say in this data, this is population mean. Let me give you a sample from this data. So let's take 75, 43, 48, um, 35, and then 52. Now, the difference between population and sample is that for population, let's say we are dealing with the KNUST School of Business, right? Now, KNUST School of Business, if you want to find if the KNUST School of Business first year student sits for business statistics. Now, if we take the entire year one, second semester for business statistics, that is the total population of students who sat for what? Business statistics. And that is this. Now, if we take like 10 students among these 10,000 plus students, then it is a sample of what? The entire population. So we are not going to deal with the entire population. That is going to be a bigger work to do. So we take a sample and then we base on the sample to do what? Our analysis. So instead of dealing with all of this, we will take a sample and then we try to use the sample mean to find what? The average. So here we say that the sample mean x bar is equal to the sum of x divided by n minus 1. Okay, x n minus what? Minus 1. So that means that this will be equal to 75 plus 43 plus 48 plus 35 plus 52, all divided by 5 minus 1. Do you get it? So this, is going to give us 253 divided by 4. And that's going to give us 63.25 marks. So whenever you are asked to find sample mean, this is how you do it. And whenever you are asked to find population mean, this is how you do it. Now in your slides, you have a couple of questions, a number of questions that you can try your hands on as well. Right. Now we are done with arithmetic mean. Let's go to weighted mean. So weighted mean, for example, in weighted mean, we have a practical example how your CWA, how your average is calculated, let's say per semester. What we do is that to find your average, we use the credit hours in each course, and then we multiply it by what? The marks you get in each course. So the weight of a particular um, 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 course depend on its credit hours. Do you get it? So let's say you have 1 credit hour per course, and then you have 3 credit hour course. So if you score higher marks in the 1 credit hour course and score lower mark in the 3 credit hour course, the 1 hour credit is not going to affect your average by much. Do you get it? Yeah. But if you score higher marks in the 3 credit hours, it affects your average, significantly. Do you get it? So in doing so, how do we even calculate for the average in the first place? Yes, this is still average. Okay, just that we have, instead of each of the x value representing themselves, no, we have weighted, or sorry, we have credit attached to it. Okay, and in so doing, we say that if you want to find a weighted mean, which is say x bar w, it is equal to the weight of the first times the x value plus the weight of the second plus its x what? Sorry, times its x value plus the weight of the third times the value of the third, till you get to the weight of n times the value of n. Okay, so you can have almost tens and hundreds of it. So if you want to calculate your average, this is how you are going to do it. So let's say you have 8 courses. That means you are going to have this up to W8 X8. Okay, all divided by W1 plus W2 plus W3 to W what? N. So in short, we can say that weighted mean or weighted average is equal to sigma Wn xn divided by W. Right? Or let better still, we can say it's Wx. Yes. So this means that the weighted the summation of all the x Wx values divided by the sum of the W values. Let's take a practical example. The quality construction company pays its hourly what? Employees 6,500 Ghana cedis. This question is in the slides. And then 7,500 Ghana cedis and 8,500 per hour. So you say you pay 6,500 and then 7,500 or 8,000 what? 500. So at the end of the period, we had 26 what? Hourly employees. So 26 hourly employees who are going to be paid what? 8,500, right? And then we have 14 that are paid. So there are 26 hourly employees, right? So the total number of workers is equal to 26. And then out of the 26 hourly employees, 14 are paid what? 6,500 rate. So 14 of them are paid 6,500 Ghana cedis. And then 10 are paid 7,500. 10 are paid 7,500. And then 2 are paid 8,500. Is that so? 8,500. So the question says that what is the mean hourly rate? What is the mean hourly rate for if we pick, so this means that if we pick one employee randomly, it is presumed or it is assumed that the person takes the average what hourly rate that we are going to calculate for. So what we need to do is that in order to do this, we see that x bar w is equal to, we are using this method. We have three. So we have x1, w1, x2, w1, x1, w2, x2, x2, w3, x3. Now, these are the w's, right? And these are the x values. Please know the difference. Know the difference. These are most of the time, the w values are this the least values, and these ones are the higher values. Okay, mostly. So make sure that you don't interchange them. Okay, so let's find our w1 is 14 times 14 times 6,500 plus W2 is what? 10 times 7,500 plus 2 times 8,500. All divided by, here we don't have to add all this because he has given us what? The total number of employees, which is what? 26. Therefore, we can say that X bar W is equal to, so feel free to pause the video and then calculate it yourself. So here we have 9,100 plus, 91,000 plus 75,000 plus and this is going to give us 17,000. Right. So we divide here by our 26, and this is going to give us 17,000 plus 75,000 plus 91,000. It is going to give us 183,000 divided by 26. And this is going to give us 7,038.46. Okay, so that is how we calculate for weighted mean in this case. Right, so we have a question here. If you don't have the slides, you can write. Is it in a company having 80 employees, 60 earn 10 $10 per hour and 20 earn $13 per hour. A, determine the mean earning per hour. B, do you believe the mean hourly wage to be a typical? So this is a very critical question. I leave it to you. You do it. You send it to me, or you comment it. You comment your answer in the video below, or in the comments. And of course, if you get your answer to, you can send it to me personally on my number via 0246791012. I'll look at it and I'll congratulate you if you are right, correct you if you are wrong. Right, so we can move on to, this is geometric mean. Since we are on mean, let's jump to geometric mean, leaving mode and median, which we will come back to them some other time. So let's go to geometric mean. Now, we have two types of geometric mean. We have one, geometric mean, that is used to find the average of ratios, indices, percentages, and stuff. The average. Do you get it? So if you have three percentages and you have to find the average, geometric average, we have a way that we do it. And then if we want to find our percentage increase, right? Percentage increase. That one too, we have our way of what doing it. First of all, let's look at geometric mean. Right. So in order to find geometric mean, we said that geometric mean GM is equal to the nth root of x1 times x2 times x3 to xn. So that is the formula. Let's take a practical question. We said the profit earned by, so example 3.11, example 3.11. He said the profit earned by Consa Construction Company on four recent projects were, so the how do you call it, the profit on four projects were 3%, 2%, 4%, and then 6%. So if you ask to find the geometric mean, the geometric mean in this case is equal to the nth root. What is n? N is the number of what? Observation. Mind you, in statistics, mostly when you see n, we are talking about the number of what? Occurrences, the total number of observations. Here we have what? 4 total number of observation. So it's going to be the fourth root of what? 3 times 2 times 4 times 6. Are we together? So 3 times 2 times 4 times 6 is going to give us what? The fourth root of 144. And the fourth root of 144 is what? 3.46. 3.46. So that is the 3.46%, right? Since we are dealing with percentages, 3.46%, right? Then we also have the second application of geometric mean, that is to find an average in what? Percentage increase over a period of time. So this is how we do it. With geometric mean, that is going to deal with the percentage increase in a period of time. Then we say that geometric mean is equal to the nth root of the value at the end of the period. So value at the end of the period divided by the value at the beginning of the period minus 1. Okay, minus 1. And then we have a practical question. Example 3.12. Is that the population in Ghana in 1988 was 2 persons. So in 1988, the population was what? 2 persons. And by 1998, it was what? 22 persons. So is it that what is the average annual rate of percentage increase during during what? Yes, what is the annual rate of percentage increase during what? 10 years between what? The 1988 and 1999. That means that it has been what? 10 years. It has been what? 10 years. So if you want to find the annual percentage increase, then it's going to be what? We say that we have to use the geometric mean. So the geometric mean in this case is n. Now, know that n is equal to 10. N is not equal to 2, as we did here. Here we see the number of is what? Is 4. So n was equal to what? 4. Here you only have 2 values. It doesn't mean n is equal to 2. The period. So it's being calculated annually. Though that means at the end of the 10 years, it will be calculated 10 times. That means n is equal to what? 10. So it's going to be the 10th root of the beginning. The value at the end was what? 22 over the value at the beginning, which is what? 2. So this is going to give us the 10th root of what? 22 divided by 2, that's 11. And the 10th root of 11 is going to give us what? 1.27%. And that is the percentage increase in the period. Right. So this is how you find geometric mean when you are looking for average of a total number, and then when you are looking for percentage increase. So these are the two applications of what geometric mean. Now let's go to where we skipped, that is the mode and then the median. The mode and then the median. Now, note that with arithmetic mean, mode and median, we are going to look at it in terms of grouped and ungrouped data. Okay, we are going to look at it in terms of grouped and ungrouped data. So, let's look at mode. Now, we said mode is the value with, or let's say the most occurring value. Most occurring value. So, when we look at mode, we say that if we have a data, say okay, let's have this data. Let's say we have 5, 3, 2, 1, 1, 4, 3, 1, 1, 1. Right. And then let's say we have 5, 3, 3, 3, 1, 2, 2, 1, 2, 4. Now, you see these two. These are all a given data. So we are looking at mode. The first thing you need to do when you're asked to find mode for this is ungrouped data, right? Mind you, this is ungrouped data. First of all, you need to form an ascending array. I said what? You need to form an ascending what? Array. Now, in forming an array, the first one A and this is B. We are going to have 1, 1, 1, 1, 1, 2, 3, 3, 4, 5. Right? And then this is for A. And for B, we are going to have 1, 1, 2, 2, 2, and then 3, 3, 3, 4, and then 5. So this, we have formed an array. Now, we say what is mode? The most occurring value or the highest occurring number, right, in a data set. So when you look at it, you realize that here, one has what? 1, 2, 3, 4, 5. So the mode is simply what? 1. But when you look here, 1 is 1, 2. Yes, 2 is 1, 2, 3. 3 is 1, 2, 3. 4 is 1, 5 is 1. Here we have two numbers occurring the same time, the same number of what? Occurrences, having the same number of occurrences, and they are what? Equal. So this is occurring 3 times, this is occurring 3 times, and this is what we call multimodal what? Data. We will call them the multimodal data. So it means that we have more than what? One. We can have three, we can have four. So any mode or any data that has more than one mode or more than one value occurring the most, we call them what? Or we call it a multimodal what? This thing. So here the mode is simply going to be 2 and 3. That is simple, right? Okay. Then we move on to mean. Let's use the same example, right? Mean. Sorry, median. Sorry. Let's move on to median. The middle number. The middle number. So this is how you find the median. Now, okay, let's see. 2, 4, 6, 2, 4, 6, 8, 10. 2, 4, 6, 8, 10. Okay, let me add 9 to this, 9 to this. So here we have 11 numbers. Here we have 10 numbers. Right. So this is how you find a median in any given data. First of all, we say rearrange it in order of magnitude. That is from the lowest to the highest. That is what we have done here. We have formed the arrays, right? Then the next step is that let n be the number of what observation in the array, right? So here for this one, we say that n is equal to 10, and here n is equal to what? 11. So we have done that, right? And here is the condition. When n is odd, the middle value is what? Half n plus 1th value gives what? The median. So if n is odd, we have a condition. Condition 1 says that if n is odd, then the median is equal to half the n plus what? 1. If n is odd. So if you have an odd number like this one where we have 11, 11 is an odd number, right? So if 11 is an odd number, then here we have, what do we have? N is equal to what? 12. So the mode, and this is the position. This doesn't give the exact number. This gives the position. Please, mind you, this gives what? The position, not the exact number. So that's why we had TH. So it's showing you that, or it's telling you that this is going to give you the position of the number. So here we have m equals half of what? 11 plus 1. And then this is going to give us what? Half of 12, which is 6. So the sixth number, 1, 2, 3, 4, 5, 6, 3. So this is the sixth number. So therefore we say that m is equal to 3. Now the second condition, let me write here. The second condition, we say that if when it is even, that means there are two middle numbers. The arithmetic mean of those two numbers gives the median. The arithmetic mean of those middle numbers gives the median. That means that the mode, if n is even, the median is equal to, then the mean, that is sigma x of what? The middle, the two middle numbers right? The mean of the two middle numbers. So here the median. So what are the two middle numbers here? So we have one taken away, one, one, one. We have 1, 2, 3 taken away. We have one, we have one. So we have 1 and 2 in the middle, right? So the median is going to be 1 plus 2 divided by 2. Do you get it? So this is going to be what? And mind you, this is not position, okay? Yeah, so this is 3 over 2, 3 over 2, and that's going to give you what? 1.5. So that is how you find mode and median for on group data. So we are going to look at how to find mean, mode, mean, mode, and then median for grouped data, and you need to pay very much attention to them.